Algebra 2, here's your homework video for the week. I'm going to try to get it done in a half an hour, so it's not too long. You can always fast forward, of course, and rewind as well. So lesson 61, number 7. So let's just get going with this one. It is in rectangular form, 6r minus 2u, and we are to change that into polar form. So this is the same thing as if you had 6, negative 2 in rectangular coordinates. So the first thing you want to do is you do want to draw a triangle. So I'm going to draw my axes here like this, and we're just going to we don't have to be accurate, we just really need to find out what quadrant this is in, and you'll see why in a minute. So if I did 6, negative 2, let's just say it looks like that. It's going to be over here, it's going to be over here 6, and down negative 2. Obviously it's not to scale, but we're trying here. All right, so let's put the sides on it. So we have this side is 6, and this one is a positive 2. We're talking distance, so we don't want to have a negative distance when we're doing our triangle. Okay, we'll call this h. We'll do the Pythagorean theorem. 2 squared plus 6 squared equals h squared. And we're going to get h squared equals 40. And the hypotenuse is the square root of 40, which can be simplified to root 5. Okay, that's the length of the vector. Now we need to find this angle right here. All right, we're going to use the tangent function for that. So we would say the tangent of theta is opposite over adjacent. You could do 1/3, it works just the same. Now to get the actual theta, we're going to do the inverse tangent. The inverse functions give you the angle. So I'm going to pop that in my calculator, and we get 18.43 degrees. Now the thing is, this theta is 18.43 degrees, but what we want is the angle from the x-axis to the vector. So it's going to go around this way, which is basically, if this one in here is 18.43, this is 360 minus 18.43. So the actual whole angle that you're going to use is 360 minus 18.43 degrees. And so now we can write our vector. The length of the vector is 2 root 5. When we subtract that on our calculator, we get 341.57 degrees. And that is the answer to our first problem. All right, next problem. You can rewind that. I erased it pretty quickly there. Just moving on, trying to keep it going. Okay, number 9, as you can see, we have a lot of problems. Okay, we're going to solve this one by completing the square. It has a coefficient in front of the x squared term, which will throw you a little bit because you're going to fraction, but they're not that difficult of fractions. If it's quadratic, exponent of 2, everybody goes to the left. 5x squared minus 4x minus 4 equals 0. Now we're going to, you can't have a coefficient of your x squared term, so you have to divide everything by 5. And then, of course, you're dividing 0 by 5, but you know it's 0. Okay, let's see what we got. We have x squared minus 4/5 x plus, I'm going to pop this other guy on the other side because he is not a perfect square or the completion of the trinomial. All right, now to get the missing guy, you take your 4/5, you divide it by 2, which is the same as multiplying by 1/2, and you square it. So it's going to be 4, that would be 10 squared is 100. Of course, you could reduce that. Whatever makes you happiest. And we factor it because it's a perfect square trinomial. It factors into x minus 2/10. You could reduce that again. Equals, now if I add those two fractions up, we're going to get, whoops, you know what? I didn't square this. This should be 16. 16. This is 4. And this is 16. Ooh, we got to square that. So this is going to be 4/10 when you square it at 16/100. All right, so now this should be, I wrote 4 again. This should be 16. All right, when we add those up, we are going to get 96 over 100. Sorry, that got messy there. All right, square root plus or minus of both sides. You're going to get 2 answers with a quadratic, right? So it's going to be, we're square rooting both sides, such as this, plus or minus. So it's going to be x minus 4/10, you could reduce that, equals plus or minus the square root of 96. I'm just going to make that a 10 there because square root of 100 is 10. Now we have to simplify it, so we're going to get x equals, when I move it over, I'm going to reduce it. I'm going to take out the 96 can be, I did the little tree thing, and we get 4 root 6 over 10, but this can be reduced. So this would be a 2, this could be a 5, and your final answer is 2/5 plus or minus 2 root 6 over 5. All right, rewatch that if you need it to go slower. All right, next one, number 10. Oops, not number 10. It's number 11. All right, 11 is the blob problems. Guys, you got to get the blob problems. Now, you're looking for places where it comes close to crossing these grid lines, and there's blobs all around, right? And I'm just going to pick, there's a line, I picked the best one. It didn't actually go totally in the second spot. So I looked on the blobs, I picked 2 points. So the first one was really clear, 110. The second one, it was a little bit above the grid line, so I just changed it a little bit. I think I made it 1.5 and 32. I made it 32 instead of 30. Just the whole idea is you're going to get close to the right slope. You might not get the exact answer in the back of the book, but just make sure it's somewhat close. So once you pick these 2 points, you're going to find the slope. And the slope is where we subtract the y coordinates. 32 minus 10 is 22. And we subtract the x coordinates, which is 0.5. I just put that in my calculator and I came out with 44. The answer in the back of the book is 42, but it's pretty close, right? Okay, now we're going to take a point. I'm going to use this one. We're going to take y equals mx plus b. I'm going to put the 10 in for the y, the 44 in for the slope that I just found here. We're going to use this x, which is 1 plus b, and we get b is negative 34. I do believe they have 32 in the back of the book. Now we put our m and b back in, so we get y equals our m that we found is 44. We put x back in, minus 34. And if you look at the book, it does look like it's going to cross the y-axis somewhere negative, and negative 34 is pretty close to 32. So be happy with that. It's really hard to get the exact numbers when it doesn't cross the grid lines exactly. Okay, next one. Alrighty, what is it? The next one is number, I might go a little bit out of order, but I'll try to get them all in. Okay, the number 19 is the square root. You guys did a good job of getting a lot of variety here. Lots of variety. Okay, first thing you want to do is you want to get these bases the same. So 32 can be written as 2 to the 5th. So I took the 32, I wanted the same base as this one. This is 2 to the 1/2 power if we change our radicals into fractional exponents. And this whole radical is over everything, so I put parentheses around everything. Now I'm just going to add these together to 10, 11 halves. And I did it differently when I did it before. Times 1/2, and that's going to be 2 and 11/4. The other way you can do it is you can multiply this through and then add it. This way is actually easier. Okay, that's 19. Next one, it looks like it's 25. 25 is a similar triangle problem. So let me see if I can draw this real quick. 25, I forgot to write down 25. All right, so, that's kind of what it looks like. 25, quickly here. These are right angles. Ooh, I did it upside down. Darn. Okay, hold on. Got to draw it the right way. All right, it goes this way, and then it's this way up, and then it's this way. I mean, I could have done it that way, but let's just be accurate here. Okay, 25. So we have 5 and 12. They tell us these are right angles. We know that these are congruent because they're vertical angles, and if you have 2 angles in one triangle congruent to 2 angles in the other, you know the triangles are similar. And if they're similar, that means their sides are proportional. So we had to find this side in order to we're trying to find C. And we have, this is 4, this is B, and this is A. So in order to get C is the one we're trying to get, you have to get A, or do you? Yeah, because these are both hypotenuses. Okay, so this is a 5, 12, 13. It's a Pythagorean triple, which means it doesn't have radicals in it. You can memorize that, 5, 12, 13. I memorized it so I didn't have to do the Pythagorean theorem, but if you need to do the Pythagorean theorem, go for it. All right, now I'm doing ratios. So the left is to the right as the left hypotenuse is to the right hypotenuse. Cross multiply, we get 5c equals 52, and we get c equals 52 over 5. Easy when I do it, right? Okay, next one is 27. Just kind of don't want to be here all day. 27, you are supposed to solve by graphing. So the equations are, hold on, let me write them down. Solve it by graphing. Then you're supposed to use elimination or substitution to find the right answer. Don't stop short of using elimination or substitution to find the accurate answer. First thing, in order to graph it, you need to put them in the form y equals mx plus b. We've been doing this since the beginning of Algebra 1. So we're going to subtract the x from both sides and divide by a -2. And we get y equals 1/2 x plus 3. All right, and then we are going to just subtract the x, so y equals -x minus 1. We're going to graph these using the slope-intercept in order to graph it. So here we go, y and x, told you I'm obsessed with that. We are going to do the first one, it's 3, 1, 2, 3, put a point. You're going to go up 1 to the right 2. You can keep going. You can keep going up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2. But I'm just going to pop that on there and draw my straight line. Oops, that wasn't very good. Oh no, I just erased the whole thing. And there's no like getting anything back on this one. All right, so I have my lines written down. I hope you do too. So here we go, y and x. The first one was y equals 1/2 x plus 3. So we got our 1, 2, 3. I have a little delay on my writer. So up 1, over 2, there you go. Connect it. Oh boy, I'm not a good connector. I'm going to make sure I don't hit the wrong button this time. And I'm trying to hurry. There, that one's pretty good. All right, now I'm going to graph the second line. I think I'll do the second line in a different color, just for fun. Okay, so the second line was y equals -x minus 1. So we're going to go down here to -1. The slope is down 1 to the right 1. So it is a negative slope. Connect those two guys. If you did this on graph paper, I highly recommend, especially if it's on a test, because you'll be able to see it more clearly. I'm going to just write some grid marks over here so we have kind of even 1, 2, right? And it looks like, I'm going to take a guess. I don't know. I didn't use graph paper. I don't have graph paper on here. I'm taking a guess. It looks like it's like 1.7 negative, right? Your x is going to be negative, and your y looks like it's going to be 1.2. Now, I actually solved it by elimination, which I'm not going to do here. And when I solved it by elimination, I got x equals -8/3, which is 2 and a 2/3. So I'm a little bit off, but I'm in the negative direction. I didn't use graph paper. And y equals 5/3. So, hey, that's not too bad for my y, right? So make sure you do it both ways. Graph it, guess your point, eliminate or substitute, and get your accurate point. And make sure this kind of matches up. On the test, I will not give you full credit if you even get this perfect without doing the elimination or substitution. Okay, that guy was number 27, and you can see all we need to do now is 29. Woohoo! Okay, 29 is one of these. These just hang on and hang on and hang on. Okay, 29 is find the equation of a line that passes through the point -2, 4 and is perpendicular to the line 2y, 2x, 2x plus 3y equals 5. All right, if it's perpendicular, it means it's going to have the negative reciprocal of the slope. So you need to find the slope. 3y equals negative 2x plus 5. We have to put it in y-intercept form, negative 2/3 x plus 5/3. Okay, put it in that form. We want to get an equation of a line that's perpendicular to this, so the slope is going to be the negative reciprocal, so our slope is going to be that, and it's going to go through the point negative 2 to 4. So we need to just plop those into the y equals mx plus b, because we have the m and we have the point, we need the b. So I'm going to write this y equals mx plus b, plop them in. 4 equals 3/2 times the negative 2 plus b, and we're going to get b equals 7 when you do all that little mathy stuff. And you put the slope and the new y-intercept in. Y equals 3/2, this is your perpendicular slope, plus 7. And that's the equation of a line that goes through the point, negative 2, 4, but is perpendicular, which would mean it would have the opposite inverse, negative inverse of the slope. All right, one lesson down. That took a long time. Okay, onward. Lesson 62. Here we go. Lesson 62 is this is a completing the square problem, but I'm going to do it even though I did one because this one has the complex number thing going on. So we are now in lesson 62. I'm going to do A. It's 5x squared. The first thing you want to do is set it equal to 0 because quadratic. Then you can have a coefficient of the x squared term, so we divide everything by 5. So we get x squared minus 1/5. That's 1/5 x, in case you're confused by that. Plus, I'm going to pop this guy on the other side and get the replacement guy. And whatever you do to one side, you do the other. How do you get the replacement guy? You take the number in front, the coefficient of the x term. You can use the negative, but we're going to square it, so it's going to become positive anyways. So we're going to get 1/5. We're dividing it by 2, which is the same as multiplying by 1/2. So we're going to get 1/10. And I'm going to square that and get 1/100th. So we're going to get 1/100 on this side. All right, this is a perfect square trinomial, so it's going to factor into x minus 1/10 squared. And when we add these on the other side, I took the top and bottom by 20 and added them together, and I got negative 59/100. Okay, this is what makes it complex. In the past, you didn't get a negative. Because when you take the square root, the plus and minus, because you need two answers for a quadratic equation, you're going to get x equals, it's going to be 1/10. This would clear the square, and I'm bringing that to the other side. Plus or minus, I'm going to pop out my I. So it's going to be the square root of 59. It's not going to be negative anymore because I took the I out, over 10. Square root of 100 is 10. Okay, hopefully that made sense, and it was another example of completing the square. Okay, next one is number 8. So 8 it is. 62, number 8. Okay, you guys had a lot of these on there. It might have been the same person, I'm not sure. But these there's fractions and decimals in equations, and you need to solve them simultaneously. So the first thing you want to do is get rid of your fractions and decimals by, I'm just checking to make sure I'm still recording this. I'm not sure if I am. Hold on. Okay, looks like I am. Okay, whew, that would be a nightmare. Okay, so we're going to multiply everything by 3 to get rid of the fraction. So everything by 3. So we're going to get x plus 2y equals negative 3. That was pretty easy. We have to move the decimal point and the number of places to make all of these whole numbers, the most number of places, so that they're all whole numbers. You have to do the same to all of them. So this goes over 2, so it's going to be 2x plus 40, I had to move that over 2, equals 258. I'm going to solve this using elimination. Let's multiply the top 1 by negative 2. Alrighty. So negative 2 let's take that through. So we're going to get negative 2x minus, minus 4y equals 6. And then we get 2x plus 40y equals 258. Add them up, the x's eliminate, we get 36, or 44. Ooh. Did I copy something wrong? Okay, this was negative to start with. Oops, so it's going to be positive. Okay, of course that just erased. This is going to be positive. This is supposed to be negative. I think I copied it wrong. Or I copied it wrong in the beginning. I don't know. We're just going to finish it. So we're going to get 44, y equals 264, and you get y equals 6. You plug this answer back into here, and we're going to get x equals 9. So let's see, did I copy it wrong, or, yeah, I copied it wrong. So this is right. Okay, so these are the two answers. It's the same as doing elimination in the past, except you need to get rid of your fractions and your decimals before you start. Just makes it a lot easier. I wouldn't want to do it without doing that. All right, another one done. All right, so let's move up. Number 12. 12, okay, so it says the volume of something, the volume of a cylinder is 11.520 pi. You need to know the formula for a volume of a cylinder. It's probably in the back of your book. But the volume of a cylinder is the area of the circle times the height. So the V part is 11.520 pi. And then we have it equal to pi r squared, and we know that h is the height, which is 20. The pi's cross out. If we divide both sides by 20, we're going to get 576 equals r squared. Take the square root of it. You don't need the plus or minus because it's volume, it's a radius, which is a distance. So the radius is going to end up being 24 inches. This happens fairly frequently where they give you the volume part. So just plug it into the right place, and then everything else is solvable. All right, so that was number 12. Moving on here. So let's move to number 18. Let's see if I can find it here. 18. Ooh. 18 is we're changing. So we're on 18. So we are changing 600 cubic centimeters into cubic feet. Oh, let's see. Is that 18? No, 18. I did the wrong one. 18. Yeah, 17 was harder. Good thing you had to do that one. So we're taking 20 cubic yards into cubic centimeters. So everything's just going to happen 3 times. So I'm going to whip through this guy. So we're going to have 20 yards cubed. We're going to go into feet to inches to centimeters. So I'm going to go feet. So we put the yards down here. 1 yard in, there's 3 feet in 1 yard. So I'm cubing everything. I'm just going to put it inside. So like this would be 1 cubed, but I'm not going to write the ones. All right, now feet into inches. So feet cubed down here. There's 1 foot, and it's 12 inches. So I'm going to cube it because everything's cubed. Inches cubed. And finally, we're going to go into centimeters. We're going to put our inches cubed. There's 1 inch and 2.54 centimeters in 1 inch. This is going to be cubed, and this is going to be centimeters cubed. So you just write your answer like this. 20 cubed, 3 cubed, 12 cubed. All the units cross out. 2.54 cubed, centimeters cubed. All these guys cross out the whole way across. All right, so when it's cubic, you can just cube it right there. You don't have to write it 3 times like they do in the back of the book. All right, check. Got another lesson done. Yay. Well, no, we didn't. I got a little ahead of myself. Okay, 22. 22. You guys put down 2 of these. I'm going to do 1 of them. So square root of x, y to the 7th, and the cube root of x to the 5th, y. So these are radicals which can be written as fractional exponents, Whatever's on the seat goes on the bottom. So these are square roots, so the 2 goes on the bottom. Alrighty, and this is a cube root, so the 3 goes on the bottom. Multiply it through x to the 1/2, y to the 7/2, x to the 5/3, y to the 1/3. We're going to add the x's. I found a common denominator of 6, so it's x to the 13/6. If you have to use your calculator for this, you know, whatever. 23/6. If you watch this video, I want you to let me know tomorrow, and I'm going to give you extra credit if you got to this point. Don't tell anyone, please, or it'll ruin it for everyone. Okay, 22. Next one is 28. 28. You know, these take a long time to make. I like you to watch them. Not because it took me a long time to make, but because you need to watch them. So x cubed minus 15x squared. This one's solved by factoring. Yahoo, I love these. Plus 50x equals 0. By factoring, you still set it equal to 0, just like you're going to do completing the square. But you're going to take the x out. You're going to get x squared minus 15x plus 50 equals 0. We break it into two binomials. What times what gives you x? That would be x and x. What times what gives you 50? But when you add them, you get 15, and that would be 5 and 10. Minus, minus. Set each of these equal to 0. So you're going to get x equals 0. It's going to equal 5, and it's going to equal 10. That was the speed version of that. Okay, next big lesson, and then it's a shorter one. So a lot of people must not have gotten to lesson 64 by noon. Okay, lesson 63. Here we go. Here's 63 right there. All right, 63. Okay, so we have on this one a new problem. I'm going to show you the speed version of these. I think you'll like them. You'll be happy about that. We have tracker left the cabin and traveled 25 miles at a heading of 20. Okay. So you can sketch these a little bit. So he left at 20 degrees, right? 20 degrees. Oops. Why do I write 30? Okay, 20 degrees. And he went 25 miles. All right, so we're going to figure this one out. You know, we can just do a little, a triangle thing. 20 degrees, 25. That's where he ends up. And then you just do a whole new one for the next one. You are going 50 miles at 215 degrees. So if you did like a little axes thing, 215 degrees, this would be 180, this would be 270. So 215 is going to be somewhere in here, so it's going that way, and it's 50 miles. So this is your 215. Okay, check out this way to do this. This is in polar form, so I'm not going to do the next one that's like this, so I'm going to write this in polar form to show you. So this is 25 at 20 degrees. This one is 50 at 215 degrees. Okay, check out how I do this. We are going to change this into rectangular coordinates, so we need the x and y. X goes with cosine, so it's going to be 25 times the cosine of 20 degrees. Check this out. Plus, I'm going to add this one right on here. So it's 50 cosine of 215 degrees. Ooh, I'm going to run out of room. I'll leave a space to write the answer. Then y is 25 sine of 20 degrees plus 50 sine of 215 degrees. So I just plopped this right in my calculator, went right across. 25 cosine 20 plus 50 cosine 215, no parentheses, nothing. I just put it all in there, and I had an answer pop out, which was negative 17.47 or negative 17.5. That's your x. Okay, and your y, I popped that in my calculator, and I got negative 20. All right, you just need to put on there, since it's a word problem, we're going to have words on it. So if you're going negative on the x-axis, that's going to be west. So we're going to write our answer 17.5 west. And if you're going down on the y-axis, that's south. So you'd say 20 south. And that is about it. Not bad, right? When you do it this way. And there's another one like this, you're going to do it the same way. Okay, say goodbye to that one. Moving on. 5. Oh boy, you guys like these too. All right, so these are chemical problems. I just always start just writing them. There's 3 carbons, 7 hydrogen, and 1 chlorine. You take it times their weight. So this one is 12, this one is 1, and this one's 35. So that's going to give you your first column. So it's 36, 7, 35. Add those all up, it's 78. Okay, do that first. Next one, they tell you the carbon was 48. So carbon's 48. This time we want to know what the total was. These are irrelevant. We don't need them. Set up a proportion. 36 over 78 equals 48 over x. Cross multiply. You get 36x equals 3,744. You divide by 36 and you get x equals 104. Put your units on there, grams. All right, that was number 5. Number 7 is just like I did on number 1, or A, okay? Number 7 is you have, I'm going to write it down, I'm not going to do the whole thing. 30 at 45 degrees plus 10 at 160 degrees. And you're just going to do this. I'll do the first one. You would say x equals 30 cosine of 45 plus 10 cosine of 160. Put it through your calculator, get an answer. You do the y, would just replace these with signs. So moving on. That was 7. The next one, we are on number 9. Number 9, I did one of those. That's where you have the fraction and the decimal. So you get rid of fractions, move the decimal over. Number 13 is a kind of interesting one. I can't draw it, as you people know. So it's going to look like this, and then we have a little triangle in the front, like this, and then, you know, this has to be like parallel to that somehow or other. And then we have, I need to go a little further, and it's going to go like this. Okay, so hey, that's not horrible. Okay, and then it's 3D. So I'm not going to even try the 3D thing. That would be really bad. That would be bad. Okay, so we have a triangle. We want to find the surface area. So we have to figure out how many surfaces. We have a triangle in the front, a triangle in the back. We have 2 side triangles and a bottom triangle. So let's do the first triangle. This is 3, 3, 4, and this is the altitude. So if you're going to get the first triangle, there's 2 triangles. So the triangle area of the triangle is 1/2 base times height. So the base is 6, the height is 4. And when we pop that all in, we're going to get the triangle is 12. And there's 2 of them. So the area of the triangle is 24. We'll put the units on in the end. Okay, let's do the rectangle sides. So there's sides right here, right? I got to put the side down here, 20. You need this side. Well, if you know your Pythagorean triples, this is a 3, 4, 5, so that side's a 5 because it's a right triangle. You can do this Pythagorean theorem. So the area of the 2 rectangles on the side would be 5 times 20, which is 100. And then we're going to take that times 2 because there's 2 of those, and it's going to be 200. And then we have our base rectangle. So this is our base rectangle, and it's going to be 6 times 20. 6 on the width, 20 for that. That's going to be 120. There's only 1 of those. We add these all up. These are going to come out in meters. So it's 344 meters squared, but we want it in centimeters. So centimeters, you multiply by 100, but since it's squared, we're going to multiply by 1,000, or we're going to move our decimal point over 4 places. Yeah, it's 10,000. We're going to move it over 4 places. 2 would be if it wasn't squared, but we're going to do 4 because it's squared. So 3, 4, 4, 1, 2, 3, 4, 0 centimeters squared, and comma, comma. All right, so meters into centimeters, you have to multiply by 100. But because it's squared, we're going to multiply it by 10,000. Okay, and what is next? That was 13. Number 23, I did that one with the square roots, fractional exponents. 27. Okay, let's do this one. 27. Almost done. Yay. Hopefully this is recording. That's all I have to say about that. Okay, so 27 is it's 12 times the complement. The complement is 90 minus a equals, it's 20 more than the supplement. And they tell you the supplement is 180 minus a plus 20. They did most of the work by giving you the complement and the supplement. Distribute it through, we get 1080 minus 12a equals 200 minus a, and we get negative 11a equals negative 880, and you get a equals 80 degrees. So whenever it says complement, you use 90 minus a. Whenever it says supplement, you use 180 minus a. Okay, 4 more maximum, because some of these we might have done before. So here we go. Lesson 64, number 8. Turn the page. What could it be? Oh, I love these guys. Okay, so this is new. I didn't really teach it to you. Hopefully you learned it. No one asked really many questions about it. M over C plus 8 over 2 plus m over c. Alrighty, so we need to find a common denominator of the denominator of the complex fraction. So m over c plus 8, the common denominator is c, so we need to take the 2 times the c so we can put it over the c, plus m. Alright, now we're going to flip this fraction over, so we're going to have m over c plus 8c over 2c plus m. Okay, and then we're going to find a common denominator here, which is c times 2c plus m. The m needs a 2c plus m. We're finding a common denominator. The 8 needs a c because there's not a c down here, so it's c squared. Just distribute it through 2cm plus m squared, I might run out of room, plus 8c squared, and it's all over 2, they don't usually multiply this one out, plus m. Alrighty, that was 8. Number 12, on the home stretch. Oh, you guys managed to give me all new problems for the end. No, number 18 we did. Alright, wipe this one out. Number, what did I say, 12? Okay, 12 is, let me copy it down, 2 root negative 9 plus minus 3 I to the 4th plus 2 root 3 root negative 3 plus I. All right, so the square root of negative 9, the square root of 9 is 3, but we have to pop our I out, so it's going to be 3I. I to the 4th is I squared times I squared, so it's negative 1 times negative 1, which is just 1, so it's going to be 3 times 1, which is negative 3. You got to pop your I out of these right here, so it's going to be plus 2. Square root of 3 times the square root of 3 is 3, but we pop the I out of the second one, plus I. I'm really doing this the speedy way. So this is 6I, and 1I, it would be 7I. I'm going to put them in the right order though. You should put your real number first, negative 3 plus 13I. And believe it or not, we are finally on the last one. Number 18 is another one of those fraction and decimal problems. And our last one is number 30, which I hate, but I'll do it for you anyway. Number 30 is estimate the, I gotta write all this down. That's the part I hate the most. These are scientific notation problems, and they want you to estimate. So you don't even work it really out. I'm going to try to make this as painless as possible. Over 96,478 times 10 to the 14th, and then that's times 0.123712 times 10 to the 42nd. Okay, when you're estimating, you want to get it down to one number. So I'm going to do that first. I'm going to make this 100,000. So I got rid of all the numbers except this one. If it would have been a 5 here, I would have rounded up. Times 10 squared. All right, this one, I'm just going to do 100. Okay, so the 7 is going to go to an 8. And we can just drop all those other zeros. And let's go down to this one. This one, since it's a 9, it's going to go up to 10 because this is a 6. It's going to make this a 10. So we're going to end up with another 100,000. times 10 to the 14. This is before I move any decimals and put them in scientific notation. And this one, the 1 is going to keep the 7 as 7, so 1, 2, 3, 7 times 10 to the 42. Now I'm going to move them all into scientific notation. So I'm going to move this one over 1, 2, 3, 1, 2, 3, 4, 5. I can't seem to add right now, 5. So it's going to be 1 times 10 to the 7th because I'm adding 5 to the 2. All right, this guy's moving to the left. 1, 2, 3, 4. So it's going to be 8 times 10 to the negative 4. And then finally, this one's going to move over 5 places. So it's going to be 1 times 10 to the 19. I added 5. And this one's going to move over 1, 2, 3, 4 places to the right. So I'm going to subtract 4. So it's going to be 7 times 10 to the 38. This one's not horrible because you don't really have to do too much after this. I'm going to multiply these together, so it's going to be 8 times 10 to the 3rd over 7 times 10 to the 57. All right, now I'm going to divide the 7 into 8. It came out to be 1 something low, so I just made it 1 because we're rounding anyway. So it's 1 times 10. I'm taking 3 minus 57, which would be negative 54. And this is in scientific notation because the decimal point's after the first non-zero digit. So this is the final answer. You can put 1.0 if you want. Okay, that is it. I took longer than 30 minutes, but I tried. And we'll see you guys in class tomorrow. Be patient while I get out of this.